Hi, sir. Good morning, sir.
Yeah, hi, good morning.
Software is working, sir.
Yeah,
Sir, doubt, sir.
yes,
Sir, while doing project, do we get DRM, sir?
DRM, yeah, I think we need to see for the DRM.
Okay, sir.
So, did you launch your tool?
Yes, sir.
Hello?
Yes, sir. Hello. Yes, sir.
Yeah, okay. Yeah, hello. Shall we start, guys?
Yes, sir.
Can you see my screen?
Yes, sir.
So, does
Yes.
everyone open? Does everyone open their tool?
Yes, sir.
Okay, so this is the library manager, right? That you are going to see currently. So this is a library manager, and if you enable this option here, you can see categories. Categories means here you can see. Let's say if you have in PD in our main technology library, we'll have resistors, diodes, capacitors, transistors, NMOS, PMOS, everything, right? So categories means here you can see diodes. So under the diode directory, you can see all the diodes. Similarly for capacitors, similarly for resistors, similarly for transistors, something like that option you can use for this. Show files means here you can see you will see one tab. Here, if any data.dm files are created, then those kind of files you can see here. So these two are not that much important, but it's very good to know.
What's data.dm? I mean, I have faced like some problems with that in my previous projects. I actually.
Yeah, data.dm file means actually this file contains all layer information.
Okay.
Sometimes if you, yeah, sometimes if you some because of this if you don't have any permissions for this data.dm file, sometimes the library manager is not refreshed. You will see always you will see the old data only. If someone gives second, then you can't see those, you can't update the lab manager. So in that case you have to uh, you have to change the permissions for this file. And again even after changing the permissions also, if you see the same issue, just remove that file and again invoke virtuso.
So like changing permission using chmod or something like that.
Yes.
Okay. How to see if like that is causing problem, that data.dm?
What?
How will you know in how will we know that that data.dm is causing problem? What kind of error?
You have to see in CAW window, right?
Okay.
Here you can see if something is not able to do, then here always here you can see the information about the what could be the cause, something like that.
Okay. Will it mention that data.dm?
Yeah, yes.
Maybe
Hello.
when we are deep into that practice, maybe once we can when we do some circuit, then there we can mindfully or forcefully we can uh, insert some error, and then we can see how to resolve it maybe later.
Yeah.
Okay.
See, now I just enabled both show categories and show files, right? Categories means, let's say if you, I just clicked over this library, GPDK45. So here you can see, right, all these things. If I click on everything, in cell window, it will show all the cells. Understood? Hello?
Yes.
Yes, sir.
Yeah. So guys, and one more thing is, if from today onwards, if tool is working continuously means, then I will take only layout related classes, because theory classes almost I covered all the concepts.
Okay.
So you have to practice your own layouts. Okay. So let's say if I click on bipolar, here you can see only BJTs. Correct, right?
Correct.
Yeah. So now if I click over the cap, here I can see only meme cap, because these show categories option, it's a kind of filter option. Instead of seeing all the cells here, if you enable this one, you can see categories by cells. If you turn on enable, sorry, everything, then you can see all the cells. But if if you want to see for only particularly for one BJT, it's difficult, right? Since this is a here we have very few cells, so we can find out easily. But if this library itself contains more number of cells, we need to see manually. Instead of that, if we select this bipolar option, here you can see only BJTs. Among these 6, we can easily start out which one we want, correct, right? But among the multiple cells, it's difficult, right? So that's the purpose of this option, categories. Okay.
Yes, sir.
Yeah. So, and again, this files show files means, let's say if I just clicked over here, right? And again, I clicked here npn2. That means in this cell, in the corresponding cell, what are the files that this cell is having, that files you can see here. Data.dm, pdk.data, something layout, these kind of things. Anyway, these are common views that you can see even if you turn off this one also. But if you want to see some particular files like data.dm files, pdk files, then you have to enable that one. And if you turn on library, then it will show these kind of files, layer map files and model files.
So that diva.txt.rule, that is
What?
diva.lvs.rule, right? So that is LVS file. You can see that. We can see that LVS and diva.txt files in there. So that is LVS files for rule file for LVS and DRC, right? You can see that diva.
Yes,
Yeah.
yes.
Okay.
This is for extraction.
Okay. Attached to that library itself, 45. Okay.
Yeah. Based on the technology only, this LVS rule file will be designed. Okay. So now let's come to the standard cells. So this is my test library. I think you all guys created your own test library, right? Hello?
Yes, sir.
I'm seeing 5 participants. Earlier I have seen 6 participants. What happened to one? Now only four people are joined.
Maybe it's because of me. I had joined from mobile, then I had joined from iPad and then dropped from mobile again. So maybe if it went from 5 to 6 and again 6 to 5.
No. I think from starting onwards, I have seen 5 people are joined, excluding me. But now only 4 are there. I think one person got dropped. Okay, that is their wish. I will continue. Yeah, so guys, how many of you have created your own one inverter cell layout?
I have created.
You have created, huh?
Yes, sir. Sir, in previous class, you told that schematic, how to draw schematic, sir. So can you please that show?
1 second. Yeah. So this is the schematic window, right?
Yes, sir.
So if you want to turn up this, you can see you are seeing some dots, right? So if you want to disable this one, press O. In schematic window, you just press O, and this window will come, display options. For layout, it is E. Understood? And you just select none option here. Now you can see plain window. Correct, right?
Okay, sir.
Yeah. So okay, now this is one sample schematic. What I will do is I just let me make it to read mode. Sorry, write mode. Yeah. So this is one transistor. What I'm doing is, before, if I want to draw one schematic, you just press I first. Okay. So then this add instance window will open. So here you need to mention the technology library, because all the symbols will be available in TechLib only. Okay. So here our techlib is, just a second. GPDK 45. So press I first. Here you can type browse, you can use browse option. Just go to the GPDK 45. So type PMAS. So here we'll take PMAS 1B and symbol height. You just place the symbol here, and similarly for NMAS, type I and choose NMAS here. Kept it here. So now, so if you want to design one inverter, you have to give the connections between these two, right? You just press W, then W means wiring. You just connect like this. Okay, and give input and output connections. And place the pins, both VDD, VSS, and input and output. So how we need to place pins means, you just select this option here, or you just press P. So if I select P, this one here, sorry, not this one, this is different. You just press P and then add pin name will come. For instance, you press I. For pin, you just press P. So here you need to mention pin name like input something, and direction input, uses schematic, signal type signal. Yeah, that's it. So you just attach here, then input pin will come. Now press again P. Here type out. Here you just change the signal direction to output. So then this will become, then this one is the output pin. Now you need to add powers, right? You just press I, sorry, P, and add VDD. Here you just add just type AVDD. You just type input output. You just say for powers and grounds, you just select this one. Like if it is a power, if it is a ground, you just select the ground and go here, place, and again press P. Just type AVSS. Input output signal type is ground. Come here. Yeah, and again you need to connect the bulks, right? You just connect like this. That's it. This is one Sam how we need to create one schematic. So understood? Hello?
Yes, sir.
Sir, we need to place the pins
Hello?
individual. Hello. Hello,
Can you
sir.
hear me?
Yes, sir.
Hello?
Hello?
Yeah, we can.
Can you hear me, right?
Yeah, yes, sir. You can hear.
Yeah. So did you understood how to create one schematic?
Excuse me, sir.
Yes.
Sir, we need to place the pins individually, like one at one time, or we can place it collectively. Like if we need to place the pins input, output, like at one time, is it possible?
Yeah, I think let me check. Yeah, it is possible, but thing is, one second, I'll show you the issue. See, if you press P, if you want to place pins at a time, that you can do. But thing is, for power, you need to mention signal type here to power, right?
Yes, sir.
But here you typed you typed four names, right? Like AVDD, AVSS, in now. But for all these pins, for all these labels, it will take power only. But it's not correct, right? So again, you need to change the signal type manually.
Yes, sir.
Yeah.
So if it's signal, we can place it.
Yeah. So if it is signal, then but that too, for all input signals you can place it at a time, and for all output signals you can place at a time. Similarly for all powers also. Similarly for all grounds.
Okay, sir. Okay, sir.
So any questions? You understood, right? How we need to create one schematic,
Yes.
and how can we place pins?
Yes, sir.
You have to press P and add the label and signal type and place the pin. And for powers and for instances, press I. For wiring, the press W. That's it. Okay. Yeah. Now let's come. I am pressing undo. Yeah. This is the actual schematic. I have copied from other libraries. So for this schematic, how many of you drawn layout for this? I told you, right, in previous class, you just copy one schematic, the schematic to your local library and practice one layout. Hello?
Yes, sir.
Yeah, yes, tell me. Hello?
Yeah,
How many of you have done the layout for this?
I have done, sir. Hello.
I think.
I've also done, sir.
Okay. So it is simple, guys. It's simple inverter only. Just a second. Why it is taking too much time to copy one simple layout? Okay, so whoever is done their layout, can you share your screen? I'll stop share here. Hello?
Yes, sir.
Hello?
Yes, sir. Hello. Hello.
Hello?
Yes, sir. Hello.
Yeah. See, why you guys are giving not reply, guys?
No, sir. We are
I
giving
asked,
reply, sir.
I asked one thing. Whoever has done the layout, I asked them to share their screen so that I can verify that layout.
Yes, sir. Sir, we are giving reply, sir.
Okay, but okay. Anyway, just share your screen.
Just a second, sir. I am opening VPN, sir.
Who is sharing? Hello?
Swami Charan, sir, I think.
Yeah, okay. If you share your screen, then I'll see the layout. So today I'll show you how to run DRC.
Yes, sir. 1 second, sir. I am opening, sir.
Okay. If you know how to run DRC and LVS, then you can try any type of cells like that GPDK 45. That is the main tech lib, right? So you already created your own local library, right? You just copy the cell whatever you want and try to practice the layout for that one and run your own DRC and LVS on your own, because that's the way only you can you'll get some practice in layout, right?
Hello, sir. Hello. Hello.
Shade,
Yes, sir. I shared, sir.
okay.
Can you
Open,
screen my screen? Yes, sir. Can you screen my screen, sir?
yeah, I can see you. Can you go to the project path and open your workspace session?
Okay, sir.
CD/project. You know that path, right?
Yes. One and forget. CD.
CD/project. So I'm Sharon. You attend the Unix. You attended Unix classes, right?
Yes, sir.
Then why you are typing like CD/project? You should give some space, right? Do you know that or not?
No, sir. 1 second.
Huh? You don't know.
No, sir. I know, sir.
Then why you typed like that? Again, see that see, because of your right now you are going to you are trying to go to the project path, right? So by after seeing your typing there in your terminal, I can say that you are not preparing for Unix.
Yes, sir. Sir, just no software open, sir.
Yeah, see, software is open, correct, right? But Unix classes, those are theory classes, right? So you have, at least you can see recording lectures, right?
Yes, sir.
See, guys, if you are not preparing Unix well, like you can't handle the tool well. That I can say, because if you want to deal with the tool, you should know Unix. What are you trying to do?
I'm just one open.
So I'm sure, and you first, before starting the live classes, I think for you it's better to prepare Unix classes first. I'll tell you the path. I'll tell you the path. Just type there.
Yes, sir.
cd/project/. Again, you are typing continuously, man. You have to give space between the command and the path, because it's not a single command. There should be some space between the command and the arguments.
Now, okay, sir. Enter, sir.
No.
Sam
Slash.
Sharan,
Sir,
you are not at all reading Unix.
I forgotten.
CD space.
See, each and every point I can't explain, right? You have to prepare on your own few things. Okay, just cd space
CD space
slash
slash
project
Slash
slash
AMS
slab
AMS workspace
workspace
slash
slash
AMS
AMS
lab
tab.
122.
No, it's
no wait
125.
Okay.
see, you have
My,
to
my number
Ah,
125.
okay.
So that's it.
Underscore
Underscore
workspace
yes, workspace.
slash enter.
Virtuoso WA, right?
Yeah, type ll here. What you are saying? AMS lab 125, right?
Yes,
You
sir.
just go. Yeah, you just go there. Sorry, Virtuoso WA that you can see here. You just go there. Go to that Virtuoso.
Virtuoso WA.
No. See, whenever I ask to go to certain directory, you have to mention CD. CD means
CD
change
space.
change directory.
Yeah. Space.
Wait, Swam Sharan.
Sir.
Do you know the objective of first CD command?
Yes. To open file.
Is it?
Yes. No, sir.
See,
I forgot.
CD command. See, whenever if you want to change some directory, or if you want to go to certain path, then you have to use CD command. CD itself means say change directory. So for any type of command, once you type the command, you have to give one space. Then only you have to give the arguments. Otherwise, how it will be treated as, if you don't give the space, the system will take that entire letters, like that entire characters, that whatever you type, it will treat as a single command. But that command will be not supported by the software, right? OS. Understood, right? You have to use space between command and the paths or objectives.
Oh,
Understood?
yes. Now we have to give cd space virtuoso underscore ws.
How will you give? Before I didn't tell to enter there, but you press enter and then you immediately that, because you haven't given any arguments to cd command, right? So that's why it took you. It went to home directory. Again, you need to type all these things. You just press up arrow.
Up arrow. Yes, sir.
Press. Yeah. Now press and down arrow. Now press enter. Yeah. Now press cd
cd
space virtuoso type vi and give tab. You press enter. Yeah. Now type ll.
Sir, source bash rc.
Yes. Yeah. You just source that file. No need to type everything. You just press tab. That's it. If that file is now invoke virtuoso.
Ampersand.
So you just listen the Unix classes one more time. And one more thing, you are appearing. I think last week you appeared for weekend batch class also, right?
Last week, sir. No, sir. There is no.
Okay. That is your test library, yeah?
Yes, sir.
Where nothing is there, right? Here.
Yes. I have run layout.
Okay. Okay. Wait.
Sir.
I'll show you one thing. Let me share my screen. So I think you haven't run anything, but you told me you have run.
No, sir. I have run, sir.
Then show me that layout. Where is your library and cell name? Did you save that? Okay, at least you know how to create the library and all, right? How to copy the cells.
Yes.
No. Don't create now because it's taking time. I don't know.
Okay,
Already you created. I think this Swami underscore tech.
yes, sir. But I think I didn't save that.
Okay, no issues. So you do one more time. But
Okay, sir.
okay, wait. Let me share my screen then.
Stop share.
Hello, Pawan sir.
Yes, tell me.
Is there any such options for missing files or anything?
Wait just a second.
Okay.
Yeah, now tell me.
If in case I forgot where I store my files, if I want to open that, is there any such options?
No, see, if the library and the files is not in server, then once if you lost that data, you can't retrieve that.
Okay.
That's why while doing the layout, and one more thing, if the project is not in the server, then you have to be very careful while deleting something, and while deleting something, if the project itself is not in server, then you have to be very careful. And if the project is in server, then even if you lost that thing, we can retrieve.
Okay.
But here, since it is your own local library, that means it's an unmanaged library. So here, while doing the layout, you always press F2. F2 means save. So always press F2 so that your data will be saved continuously.
Okay, sir.
That is a good habit actually. If you don't press F2, sometimes suddenly if the tool get crashed, then what will you do? The entire work that you have done till now, it will be lost, right?
Yes.
At least if you save something, some data, that cell at least you can see some data on that cell. But if you didn't save, then it will lost. Okay,
sir.
here I'm trying to create one cell, but it's not creating. I don't know what's the reason. It is very slow. So okay, I'll do one thing. I'll open one already done the already they have done many layouts, right? I open one cell. Yeah, this is okay. I'll open one AND gate. Why this cell is not even opening? So I want to create one layout for this inverter. So now right side you can see the layout window, right? I just open with the layout Excel. You know the difference between layout Excel, layout L, correct, right? Hello? Hello?
No, sir.
Yeah, see, the difference between layout L editor and layout Excel editor is, if you use layout Excel, then you will get the connectivity from schematic to layout, and then you can instantiate all the devices. Like see, if you use only layout, what you have to do is you just press I. You have to press I, and you need to instantiate corresponding device, corresponding PMOS. And again you need to press I, and you have to instantiate corresponding NMOS. But if you if you use layout Excel, and if you use this option generate all from source, you can see here you just observe here one line will come. If I press cursor over here, so you can see generate all from source, right?
Yes.
That means if whenever at the time of starting your layout, if you use this option, what it will do is it will select all the devices, what all the devices that we have in schematic, and it will dump in the layout view. Because this option is very useful, because since this is a small inverter, right, we can easily place manual also. But if we have a bigger schematic, you need to instantiate one by one, right, manually. But that will, for placing the device itself, it will take more time, right? That's why if you use this option, it will select all the devices and it will place the layout. And if you want to do manually, sometimes you may miss some devices. Ultimately, finally in LVS, if it catches something, you haven't placed this device in layout yet, then if you don't have sufficient area, all the floor plan and everything will get disturbed. So better use always layout Excel. That is my suggestion for you guys. You just always habituate with the layout Excel tool only, because layout L, all these things are expired, and even this Cadence is not at all supporting layout L tool now. If you face any issues, Cadence is not ready to provide some solutions to that, and soon they're going to disable layout L.
So you said layout L for good for something just now. Can you repeat that?
What?
Is there any advantage of layout L over Excel?
No, there is no single advantage of layout L over layout Excel.
Okay.
Okay, only thing is license cost will be very less compared to the layout Excel. But that layout L it's an old one, it's a basic one, and also Cadence is going to disable that layout L in future, because everyone is in companies, everyone use you can use layout L, but your work speed and everything, you can't see many features in layout L. Because see here in bottom section you are seeing so many options, right? All these kind of options you will not see in layout L. So everything you have to do on your own manually. And even layout L, you can't use this clone option also. But this clone option is very useful, and even it will reduce half of your work.
What does clone option do?
Clone I'll tell you in future, because you have to feel that it's not theoretical. Clone means it's simple. Let's say here you have one group, and here also one more group. If you edit in this group, all the edits it will reflect to the second group also. But these two groups should be related to the same. I mean, these two groups and schematic of these two groups should be identical. It's a synchronous copy kind of thing.
Okay.
Understood?
No, sir.
Yes.
Can you repeat again?
No, see, okay, I'll do one thing.
Okay.
Let's do edit mode. Okay, so now what I'm doing is I'm just copying the schematic and I'm placing here. So now I have two inverters, correct, right?
Yes.
Yeah. So normally, if you use layout L, what you have to do, you have to select all these devices, and you need to check the properties of these cells. And here you need to come to layout and you need to press I, and you need to select tech lab, cell name and properties, everything you need to, and you need to you have to place manually one by one. But because of this layout layout Excel, what can I do is I just simply I will press generate all from source. Okay, this schematic is not saved, right? So I just copied this one, right? What I will do is I will press, yeah, this is check and save, guys. This, whenever if you edit one schematic, you have to do this option, because if you don't do this option, if you are going to run LVS, the serial netlist will not generate. So you have to do always this one. So now if I click this one, generate all from source, this option, this form will rise, and here that by defaultly all these options will select, like PR boundary, IO pins, instances, and apart from that, you always try to enable this one. And next one is, yeah, that's it. And if I press OK, and okay, before just a minute, here you can say IO pins, right? So
what that preserve option, can you go back?
Yeah, preserve user defined mapping means actually for now, for these placement, it's not useful, but the main intention of this one is, let's say in future you want to add some dummy, okay, so that dummy you have added in layout, and the same dummy you also has to update it in schematic, but these two will not get connectivity. Understood, right? That connectivity also you have to create manually by using this option, define device correspondence. Once if you do that, then if you select this device, automatically the corresponding device will select in layout. But in future, someone has deleted this entire layout. Okay. Hello?
Yeah.
So, and at that again you want to place all the devices. So if you don't have this option enabled, then whatever the connectivity that you made on your own, like manual connectivity, except the device, remaining all device will come to the layout, but this device, the extra dummy device, will not come. You understood, right?
A bit confusing, maybe later.
Wait, I'll show you. Actually, this needs some time to get understanding. I'll tell you in this. Let's say if I disable this option, first we'll discuss with all these 4 tabs.
Okay.
So by default, this will be like this, guys. And next one is come to IO pins. IO, here you can see all the pins, whatever we have in the schematic, and the direction also you can see. So, and here by default you are seeing this width and heights, right? So that means by default it is coming with the starting metal, like metal 1, and the metal width, minimum width you have to take 0.06, height is also 0.06, and number, how many numbers are there? 1. Create, here if you see nil, then it will not create. Here if you see T, it will create. And same thing here, if you want to create label, that also you can do. Create, you just enable this one and go to options, and you just select height 0.06. These things I'll explain later while we are trying to create the pins and all. But to place the devices, it is not required. So now come to the PR boundary. PR boundary means it's our cell boundary. Here you can see always this origin should be 0, 0. Okay. This is utilization percentage. Like if the area of that PR boundary is 10 microns, so how much area among those 10 microns, how much area you want to use to place these devices? This is about estimation area only. But actual area you have to decide. This is floor plan. Here you can mention number of rows, how many number of rows that you want to keep, how many number of how many columns. Like say if it is for any current mirror circuit or differential pair, before placing the device itself, we can decide how many number of rows and how many columns, so that it will be useful for you. And here you can add some blockages, area boundaries, track patterns, clusters. Clusters means it's similar to the group of group cluster. That's it. But all these options for placement, it's not required. But you just know the differences between all these things. Okay, and now I'm pressing OK. So see, now all devices I have seen in layout, right? I haven't kept anything. Correct, right?
Yes.
And if you press Shift F, then you can see the devices. Understood?
Shift F, right?
Yeah, Shift F. And if I don't want to see the layout, these dots, I'll press Shift E and I'll deselect this one. Now I can see only plain screen. And if I want to enable dimming, I'll do this scope on. Yeah. So this is one device now. So you can see now the difference between now you will feel the difference between Excel and layout. So here I am selecting this device. The corresponding device is selected in schematic, right?
Sir.
For all the devices, it will select. So this is the first primary advantage compared to the layout. You can't see this feature in layout. Understood?
Yes, sir. Yes.
Got
Always you practice your layouts in layout Excel only. Don't do any layout layouts, because if someone came to your desk and if you want to, if that guy is a designer and if he wants to check the floor plan that you made, directly he will see. Designers means they don't know much about the layouts, right? Layout tool options and all, right? So simply they will come here and they will select this device. If you don't use layout Excel, then this device, corresponding device, it will not select in the layout window. Then how can you get how can you know like where you kept this device? Understood?
got
Yes.
Even if I select these pins, the corresponding will select here. Even if I press A, that also will select. If I press VSS, that also select here. And if I press Y, that will also select. Got it?
yes.
So this is the PR boundary. And here, if I enable this one, let me maximize this. Yeah. Now this is the total layout, right? So what are the layers that I kept here? If I want to see only those layers, you just select this one. Then here you can see only the layers that are currently whatever we used in the layout. Understood?
Yes.
So now this is one basic layout. So this is PMAS. And one more thing, guys, in layout window, always you use one option. This that is there here. No, I think that option is not there. Okay. Yeah. So this is PMAS and this is NMAS. What I will do is I will try to place something like this. So standard cells you will keep like this, but usually better to place both PMAS and NMAS together, because then this poly will get short, right? That means you are routing with poly. That is not good thing. And you just take metal one. This is I am just explaining how to draw the layout. This is for rough layout only. You just short these two metal. Sorry, this is for source, right? So you just type connect here, and you just connect here, and you just draw short these two. That's it. Here you just select poly, press P, You just connect like this. Yeah, that's it. Again, take metal one. Connect something like this and place the contact here, and you just place the pin here. You place the pin here, here, and here. That's it. That is a simple inverter layout. But now I didn't ask about this one. See how I asked is these kind of layouts related to analog layout. But what I asked is I asked you guys to do the standard cell layout. That means you have to create this on your own, and also you have to create on this. You have to create this cell on your own. How you created this cell means here we have open schematic, right? Hello.
Yeah.
Remove this part. This is not required for us. Yeah, so this is the actual schematic. You just see this device like it is pointing from GPDK, something like this. The only thing is you have to see the gate length and total width, gate width and finger width, how many fingers we have. That's it. Only these parameters you need, and create your layout. See, this is my layout, right? So what I will do, I will delete all these things. I'm deleting this. So here I need to create my own NMOS transistor and PMOS transistor. So first thing is
wouldn't
Yeah,
that
yes.
schematic also get deleted, because like we have deleted
What?
from schematic also it should get deleted, right? I mean, whatever we delete from the layout, I just tried it now. So
No.
deleting one.
See, no. If you delete one device, it will not delete in layout. Sorry, schematic.
Okay, I was just checking that, and I just it just happened.
See, if that is there in layout Excel, then no one will use the layout Excel tool, because that is the biggest drawback, right? See, layout means it's only for schematic to layout, but not for layout to Excel. So not to layout means if you want to say know the device, then in that purpose only it will take the connectivities and all. But if you delete something in schematic, sorry, in something, if you delete something in layout, it will not reflect to the schematic page. Only for deletion operation, layout Excel will not work, because if you delete something in layout, then if the same device if it deletes in schematic itself, then designer will question you, right? Like, why you deleted this device? Yeah, that should not happen, right? If you create any one customization tool, it should work in by taking a worst case, correct, right? Let's say if you create your own script or something, if it works for particular only one application, like, and that too, that application based on your intention only, if the corresponding script works, means that is not the good idea, right? That is not the good script also. So similarly, while designing all these tools, what Cadence people will do is they will take worst case, and by taking all the considerations, they will design these kind of tools. So now yeah, so so this is the layout, right? In standard cell, how will you do is you just start with poly first. You just draw poly. Here I'm not seeing any layers right here, because I just selected use layers, but here I haven't used anything. So you just remove this one, and you just all visible. You just type poly. It came. So you just draw. What is the gate length that we have there? It's 45, right? Hello?
Yeah.
Yeah. You just press here and select. What is width? It is not 5, but we need 45 only.
How to select the poly layer? I'm clicking it, but I'm not getting. Do we have to?
How to select the poly layer?
Yeah, I have double clicked it. We have to double click it only, right?
Where? In layout?
Yeah, in layout.
No. Double click is not required. You just select one click only is enough. So that is selected.
Oh, I'm not getting. Maybe the tool is very slow.
No. See, first here you type poly and select the poly layer here. It is only one click. No need to click double time. Select that layer, that's it, and come to here. You just press R and draw like this.
Okay, R I have to draw. Okay, I think I know.
R. P is for path, R is for rectangle.
Yeah,
Yeah.
I'm getting.
Yeah, since the gate length is 45, we need to take this one as a 45 length, right? So
Yeah.
now what I will do is I will press A. A means align. So I just pressed A. That is why I'm getting this kind of symbol. And again I will press F3. F3 means F3 option is for all properties of the particular key. Let's say if I press C and if I press F3 again, I will see the properties of that command. So here I am seeing, right, what I will do is I am just taking my user space like 5.45.
For this quick align, we have to press A, right? Okay.
Yeah, A.
Okay, there I'm
Now,
getting symbol. Click.
Yeah, click F3.
Okay, I think that bind key is not working for me. It is just for brightness in my laptop. Okay, that's it. That's it.
No, then you press function F3.
Okay.
Because F3 means over the function keys you will see multiple functions, correct, right?
Yeah.
Yeah, few functions you have to enable with function key and the respective key.
Okay.
Yeah. So now see why I am using align means if you use align, that is very easiest thing compared to the stretch. Let's say if you want to stretch, see this length has to be how much it is 0.045, correct, right?
Yes.
Correct, right? You know how to get the scale, right?
A, we have to press something like that.
So guys, I am asking everyone, not only one person. Hello? Hello?
No, sir.
You know, right, how to get these measurements?
Yes, sir. Okay.
Okay, it's okay. So just press K and you just measure the length. It is coming 45. The exact 45 we should have. We should not have anything more than even at least 1.001 also you should not have, because the gate, it is a gate length, right? It should be strict. Because why I am taking 45 only means in schematic, if I see properties here you can see that length is 45 nano. That means that the same thing I am considering here. So if I want to stretch manually, I need to press S, and I need to do manual these things. But instead of this one, what I will do is I'll not even press K also. I'll not measure also. I'll press A, and I will go to the properties of this command. Here I am just giving the user space, and I am hiding this. I am just selecting, and that too I will select partial. I will do partial select. For partial selecting, you have to press F4. So then it will enable partial select. Then I'll press A, function F3, and I mentioned user space, and I'm just pressing this one. I'm selecting, and I'm just taking the partial selection option enabled. Now if you see the space is, this layer is already stretched to the space that I have mentioned here. Correct, right?
Yes.
Understood, or should I need to repeat one more time? Hello?
Understood, sir.
Yes, sir, understood.
Yes,
Guys,
understood.
yeah, one disclosure from my side. So I'll repeat multiple times. If you're not able to understand, I can repeat multiple times. But thing is, you have to remember all this and you have to practice on your own.
Practice only we will remember.
Yes, that's what I'm going to tell. If you don't practice, even if you read 100 times or 1,000 times, definitely you can't remember all these options, because there are multiple options. Once if you practice all this, then only you will get to all these keys and shortcuts will be stored in your mind. Correct, right?
Yes.
And if you do practice, if you practice your layouts, then automatically that will comes to your hands. That options, keys, that will automatically, your hand will go automatically. No need to think on it. Got it? So this is gate now. This is gate.
Yeah, I got it. A function after function F3 user defined space. Then we have to press a function F4. From that onwards.
See, wait. I'll do one more time. So this is the initial. Sorry, this is. Wait. Let me do. Yeah. So this is the initial rectangle that I have drawn here, right?
Yes.
Yeah. So whenever, if you want to stretch at one side, or if you want to stretch it only left side or right side or top side and bottom side, only one side I am saying, then what you have to do is first you need to enable partial selection. Okay. For partial selection, you just press F4. So here I am not pressing F4 because already I have enabled partial selection. Now again, if I press F4, this partial selection will go. Now it will become full selection. So now here I can't select only one edge. I can select the entire layer, but I can't select the only one. If I want to select only one edge, I can't select because that partial selection was turned off. So again, if I press F4, then now again partial selection will come. Now see, if you see, I'm able to select now, right?
Yeah.
I'm able to select one edge.
Yes.
So this is the best advantage of partial selection. So now already partial selection is enabled. Now what I will do is I will press align, quick align, and I will press F3 key. So then this option will come. This form will come. Here you have to mention your spacing, how much you want to stretch, how much you want to move. Then go height. You just select either this edge or this edge. I am selecting this edge. And so this edge got selected. Now the same cursor, this yellow color mark is coming, right? I will select this left side edge. I'll click over there. Then automatically this edge will come to here. Sorry, by 45 microns, 45 nano. Understood?
Yeah.
Okay. So again, if I don't want to press, if I don't need this partial selection, what I will do is I will press F4. Then partial selection will go. So this is the poly length, whatever I required in schematic. Now I will press here, I will select OD. No, here it is oxide. Again, I will press R and I will draw like this. Okay. Now this is the gate length. This combination of this OD and this poly, where these two are matching. Here only, right?
Yes,
Hello?
sir. Yes, sir.
Yes, sir.
Only at this portion only these two are meeting, right?
Sir.
This is the channel length. This is the transistor length. Understood?
And
Already we know the length, right?
Yeah, that's already you know the length. But in layout, see, if someone, okay, then I'll do one thing. So if you do like this, is it matches with the transistor length?
No.
No, sir.
Right. Why? How you say that?
A measurement only.
Yeah. Okay, that is okay. So again, I'm just asking one. See, one of you guys has done the layout. So I just came to this transistor and I asked you just measure the length of this transistor. I want to know. Correct, right? So how can you tell then? See,
Scale.
First,
let us consider this is one dummy transistor. So I just came to your desk and I asked you, you have to add the, you have to update this dummy device in schematic also. I asked you just measure the length. Then what will you measure? I just asked you to what is the length of this device. Then what will you measure? It will from here to here or here to here.
Second one.
Yeah, that's what I'm trying to tell, right? This is the gate length. Because since here you have a schematic, so that you can tell like I know already gate length, then why we need to measure. But if you don't have schematic, how by seeing layout itself, how can you tell? You understood? Understood, right? I think
Yes.
you are Mallika, right?
Yes.
Yeah. Now you cleared your doubt.
Yeah. Yes.
So this is the gate length. Now see, this rectangle is there, right? Oxide. I can't draw. I should not draw whatever I want. Like if I want to draw 100 microns, I should not draw like that. Again, to come to the schematic, you just check the how much width that I have in for this transistor. How much I have? 390 nano, right? So
Yes.
only that much only I need to draw because this is the gate width. You should not draw anything you want. Again, what I will do is I will press. I will enable partial selection.
Yes.
And I yeah, and A, press
Yeah,
A
like.
and F. Sorry, one more, just a second. A, F3. Here I need to give 0.039 because the width is 390, right? So now I'm just selecting this edge. So how much is length?
Not 339.
390 nano. That means it is
0.3.
yeah, 0.039.
No, point not 0.3 micro.
0.39.
Yeah, micro we are making.
Sorry, 0.39. That is why it is looking very small. Yeah. So this is the gate width now. And again, guys, so once if you are done with your user spacing, always you again enable no spacing, because if you keep on turn on this one, if you want to stretch something, then it will take you that 0.39 only always. Understood?
Yeah.
Hello?
Yes.
Yeah, all these things you will get to know once you practice your layouts. So guys, this is one transistor, guys. This is the actual transistor in the schematic. So because this width is matching and even this length is also matching. But these are the basic things. But apart from these two, there are many things like you need to place the source and contacts here. For that, you have to draw metal first. And you have to select the metal one. And you have to draw like this. And here you need to place the contacts. Same thing, you just copy, paste it here. And also, what you will do is for standard cell wise, first you should not draw the metals. What you have to draw is, you have to draw the contacts. CNT, CT. Yeah, this is contact. You have to draw like this, Like even for this contact also, you should know the DRCs, how much width and length it should have. Same here also you have to draw something like this, but there should, you have to follow some spacing between this gate to this contact. That is the minimum DRCs. For in standard cells, you have to follow always minimum DRCs. That you after placing the contacts, you have to draw the metal ones. Here also metal one. So once if you after placing these contacts, this enclosure is there, right? Oxide enclosure. This has to be, you have to follow minimum, especially in standard cells. Let's say if it is pine 04, then you have to stretch this one to 0.4, or otherwise you have to move. Similarly, at right side also, you need to remove this. Only you should have 0.04. You understood?
Yes, sir. Both sides we have to keep it equal, right?
Yes. So this is for PMOS, guys. Again, here you have to draw P plus layer. P implant layer. Select R. You just draw something like this. Whatever the layer that you will draw, it should follow some DRCs. And again, N-well. Yeah, and here you need to place one contact again, something like this, and here you have to draw metal one. So this is about one sample PMOS layout, guys. You understood, right? How to draw the standard cell. Hello?
Yes.
Sir.
Stretch this palette some little bit more only. First you draw little bit, you just draw some more length poly, and you same whatever the layers that you have drawn here, same similar way for NMOS, you just repeat all the layers, but between PMOS and NMOS you should maintain minimum space. After completing your all layouts, these enclosures, and after completing following all DRCs, you have to place the power rail and guard ring rail. And after completing all the layout, you just run the DRCs once. According to the DRC, you have to clean all. If you definitely you will get errors, those kind of errors you have to clean. Understood? Any doubts? So can I even tomorrow also for the same time I'm going to take one more class. So by tomorrow, can I expect everyone has done the layout?
Yes, sir.
Yes, sir. Hello, Pawan, sir.
Yeah, yes.
In this we have taken length, right? 0.04
4 5.
transistor. No,
Where you have taken not pine not for schematic, huh?
in not schematic, sir.
Layout, it is not 45, right? It is 45 micros. Sorry, 45 nano.
No, sir. We have take both sides equal, right? 0.0.
Yeah. See, since it's a standard cells, right? So you have to follow the same length for both PMOS and NMOS. That's the reason I'm stretching this poly till bottom. For even for NMOS also, I can use same poly. Understood?
This is for default one. We have any changes?
Change in the sense lengthwise, you are saying.
Yeah.
Yeah, length you can take anything, but according to with the respect to your layout, you should have updated your schematic, or otherwise with respect to your schematic only you have to do the layout. See, here I have 45 in the schematic, right? This length is 45. Here also length 45. That's why I took only that parameter. If you have in schematic, if you have it is 50, according to with this one, you have to consider that.
Yes.
Always you have to draw the layout which is suitable to your schematic. Otherwise, LVS will fail.
Okay. Okay.
So you understood or not? If you understood, then say yes. Because I am expecting everyone has to do their layout in their own local library by tomorrow and tomorrow's class. Can I expect?
Yes.
Okay. At least see, don't if you have time and if you know how to run DRC, then you can run. But at least the mandatory thing is I am expecting everyone has to do, has to complete, has to draw all the layers and has to complete the one this kind of inverter first one.
Sorry,
And
sorry, I dropped in between for a minute. Sorry, can you
yeah,
repeat?
see, actually, what I'm telling is by tomorrow's class, I am expecting everyone has to complete one sample inverter layout.
So for that contact lens and all, can we keep it like some maximum length or some like good length without taking DRC though, so that it will get passed in
No,
DRC
see,
LVS?
wait. So use until I start analog layout classes, always you think in perspective of standard cells.
Mhm.
Okay,
No,
in standard cells, always you have to use minimum guidelines.
from where to check that minimum oxide contact spacing or NML or
That's what I'm
oxide
telling,
spacing?
right? See, I also don't know because I haven't used this technology. I'm using different technologies now. So see, you not only me, no, in industry, no, if you give a new technology to that guy, and if you ask what is the DRC between these two, no one can say like this is the DRC spacing between them until unless he checks a DRC report or he checks the DRM. Understood?
Sure.
Yeah, what he will do is because even anyone even for if you get one latest technology like cutting edge technologies are there, right? So for starting itself, even we also should don't know DRC between the layers. First what we'll do, we'll start the layout because we know how to do the layout, right? We'll start the layout and we will run DRC slowly. All these kind of DRC errors we will remember. Understood, right?
Okay. Okay.
Yeah, but that is the actual process. It will continue in industry. But uh, before starting the new technology layouts, it's better to read DRM once or twice at least. Like how base layers are looking, what is the metal stacks that this foundry is providing, how many metals are there, what type of, is there any special type layers, something these kind of R&D will go before starting the layouts. After that only we'll start the layout and see for any if it is a lower node or higher node, if it is a different foundries, these base layers are common, guys. Only names will change. Like here I'm seeing oxide, right? Here I'm seeing oxide, right? If you go to the other foundry, they'll call it as a RX. Or otherwise, so if you go to the global foundry, they'll call it as a OD. And if you go to the TSMC, they'll also call it as a OD only. And if you go to some other foundry, SMIC or something, they will call it as a active. The layer is same, but only the pronunciation is different. Understood, right?
Yeah.
Yeah. So first, what you will do is you just finish your layout, like you draw the layer, poly layer, oxide layer, contacts, and you just take minimum, like some minimum space around 0.05 micron or 0.4. Nothing will happen. You just draw the layout, whatever you want. If you want to keep 1 micron, then also you can keep. But my suggestion is you take minimum. You get DRC error first. You just see the DRC error. Then only you can remember, right? If see, let's say if you keep 1 micron DRC, 1 micron space between these two, definitely this error will not trigger in DRC because you already crossed more than the minimum space. Then why it will rise the DRCs? Then you don't know, right? What is the minimum space between these two?
Okay.
You understood my point?
Got
Yeah, you just get the DRCs. See, for and one more thing, for new guys like you, before starting the layouts, whoever is getting the more errors, just listen this point and remember, by the end of this course only you will get to know who are getting the more errors at the initial stage of layout. He can only remember about all the DRCs for this technology. That is the only solution, because you can't read DRM, entire DRM, right? Because first of all you should know how to read the DRM. That is not possible here. So that's why you just place manually somewhere here and run the DRC, get the DRC report and clean the errors. Then you will remember this. Then for next layout, while drawing this contact itself, you will remember definitely, okay, here from this poly to here I need to maintain minimum space, and even for this contact also I need to draw in particular width and particular length. So these kind of all errors you will remember automatically. Understood?
Got it.
Yes.
So any doubts, guys?
I have one regarding that align. So when after we said that align F3 and 0.45, and again we have to press A, and we have to select then both edges of the poly, I mean, or just one edge and select at that length.
No, if you select only one edge, if you press it only one edge, it will select automatically, and you just come to the second edge and you press just click over there. Then that means you are telling the you are trying to tell to this command, just first select the right side edge and take the left side edge as a reference and move the right side edge according to that.
Okay, the second one is reference. Okay.
See, you are giving some space, user space you are giving, but that layer has to know, right? What is my reference layer? From where I need to take 0.045. That for that reference, I am just clicking at left side.
Okay.
If you don't have any reference, then how it will know from where I need to take 0.045? From where I need to move, I need to take 0.045. So it can't. We are not giving proper input, right? Then.
Correct.
That's why we need to click at the other end. Then it will take that other end as a reference. Then it will move the other edge, whatever we selected. So,
and there is like some distance between P implant and that OD. Like entire P implant is source, right? Even or just OD section is source, because P usually
no. Entire P implant is not a source. Here, whatever the contacts that you are drawing here and whatever the metal that you are placing here, that is the diffusion, source diffusion.
Yeah. So diffusion area, even if we are like drawing P implant, usually P implant is for PMOS is source, right? So entire that diagonal lines we are getting that P implant layer. That yeah. So that is entire source, right? But oxide layer, we are drawing it for the connection, but that source is entire layer, right? From that gate edge to that P implant edge left. Yeah.
No. See, this P implantation layer is for recognition. It's only just to isolate both PMOS and NMOS. This is implantation layer, but actual source area is here. This is source area. Here you are placing the contacts, right? The combination of these contacts and this diffusion, oxide diffusion, and the metal one. Metal one is for only area. Sorry, metal one is for only contacts, getting the connectivity to outside. But this is not the source. This is only implantation layer to identify whether this is PMOS.
Okay, that's just for identification, right? Okay, that's our.
Yeah, this is not the exact source. This is for implantation layers.
But in actual fabrication, the P implant will be just limited to that oxide area only, right?
No, you should not say like that. It depends on foundry. It depends on the DRCs also. Few, I think till now I have worked with many foundries, but nowhere I'm seeing this P plus layer is exactly has to align with the OD. Definitely, it will surround the entire OD, something like this.
I wanted to know the reason for that, like in our actual cross section and where when we see that, right? So just where the source and diffusion ends, right? Because
Yeah,
that's
here, there you can't see these implantation layers and all exactly. But if you see in Google or something like cross-sectional view of and all, people will never discuss about this P plus layer and what it is exactly.
yeah,
This
yeah.
P plus means it's only doping layer.
Mhm.
See, if you draw P plus here, that means you are telling to the foundry guy, you have to dope this oxide layer with third group elements.
Mhm.
Then only you will get P diffusion right here.
Mhm. Correct. Okay.
So that's why you are telling to the foundry guy, whenever he sees this layer, okay, this is P plus. So, okay, I need to dope this diffusion with the third group element so that I can get P plus.
Mhm.
Here,
But
yeah.
but our effective source and drain start from OD only. That's just
Yes,
for
yes.
fabrication. Yeah. So that we get like constant concentration. Maybe we can say that like that from all the ends by the time the OD starts. Because at the edges, definitely there will be some problem at doping will cause problem. So this is
Yes.
just that, yeah, P plus is just for the fabrication, but yeah.
Yeah, that's why I told you, right? It's implantation layer only. It's not the source drain deciding layers. It's only telling to the foundry guy, you just have to dope with the third group elements to get the P plus junctions, both at source and drains.
Okay.
Similarly, for NMOS, you will see only N plus.
Because in Google or any other cross-section images, they don't discuss about this P plus. Yeah.
That's why,
That-
right? Before you are telling this point, I already mentioned, even if you see in Google, nowhere you can see this P plus implantation layers.
Good.
Because this is for only fabricational purpose. Like once if he sees that layer, then okay, he'll that people will understand. Okay, here I need to dope with third group elements.
Mhm. Okay.
Okay. So any questions, guys? So guys, you understood how to draw the layout?
Yes, sir.
So surely I can expect right by tomorrow's class.
Yes.
Today
Okay,
evening we
then.
don't have class, right?
Today evening I have a weekend batch class. You don't
Okay.
have, because you see, even for this, even morning class also, why I took is last in weekdays I am not able to take the classes, right? So that's why I want to balance those.
From now onwards, we'll have a class on Saturday also or not?
No. We will not have Saturday, Sundays class. Since I am not able to take the classes on weekdays, that's why I took for today and tomorrow.
Okay, sir.
Understood?
Yeah.
Because continuously, if I want to take both weekdays and weekends, it's difficult for me. I need to manage my own office work also, right? Okay, guys. Yeah, yes. And Swam Sharon, you understood, right? How to draw the layout.
Yes, sir, I know, sir. I will. Yes, sir, I know, sir.
You know or you understood?
I understood, sir. Understood.
Okay. Okay, then can I expect it by tomorrow, right?
Yes,
Yes.
sir. The parameters we can take
Okay, then.
randomly, sir. Hello.
Yeah, see why I am asking this question repeatedly is, once if you are able to do this, then I will go to how to run DRC.
Okay, sir.
And otherwise, now itself I will cover DRC also, how to run, so that you draw the layout and try to run DRCs. And after seeing the report, you try to clean those so that your layout will be base layers DRC clean. And after tomorrow, I will discuss about how to run LVS. That we will see on tomorrow. So now, shall we start how to run DRC? Hello?
Yes.
Yeah.
Yes.
So here, go to Ashura, This is Assura tool, not Caliber. Assura means it is for, I think it is Synopsys tool, I think. Caliber, it is for Mentor graphics. But here we have Assura, Open Assura. Okay.
Yes,
Huh?
sir.
Open Assura. And next one here, you will see these kind of options like Open Cell, Technology, Rule Set, Setups, Run DRCs, LVS, ERC, something, so many things are there. You just run DRC, select this one, this form it will open. And here you just make sure whether you have the proper cell view and layout view, library, cell name, and after this runtime, this is run directory, this is run location, view rules file technology. Rule file.
Technology we have to select. No?
Just a second. Guys, and one more thing. So here you are creating your own cell, right?
Yes, sir.
Hello?
Yeah.
See, you always, okay, wait, let me open library manager. Yeah, so this is the main library. Let's say here, if you want to do if you want to start this layout, this one, same the layout you just copy to your test library. Here,
Hello.
I think wrong. Is that inverter copied from somewhere, or just uh, we have to create a fresh new stuff? Guys, hello.
Yes.
I mean, yeah,
Hello.
I mean, yeah. So that inverter we have to copy from that GSCLIB 045, or because I've created a fresh library for that, and it's created fresh schematic and layout. So do we have to copy it from some other library or something like that? I think so.
No, we
Sir
have
was
to.
just doing that
No, we have to create our own library and own cell.
because he now was just like going for that GSLIB 045. I think he has copied it from somewhere, right?
He had copied, but we have to create our own.
Oh, okay, okay.
So maybe he was telling that only, that the TSMC only file that is showing in the technology file. Okay, okay. Thanks.
Hello.
Yes,
Yeah,
sir.
hello. You are audible.
Sorry, suddenly I got disconnected. Yeah, just a second. Let me connect to VNC. Can you see my screen?
Yes.
Yes.
Okay. So where we are, run DRC, right? Yeah. So here you just open Ashura and run DRCs. This, yeah. So before doing this, yeah. So you just copy this cell to your local library with small letters. You just always type here. If you see INVX1 capital, you just press small INVX1, because here in run directory, here by default it is taking this path. That means this cell is already done by someone, right? And they might have done DRC and LVS, right? So if you press OK, it is asking to whether I need to overwrite this existing results. But don't do these things. You can do two things. Either you have to create one directory, you give your own path. Okay. Here what I will do is I'm just removing this PV. That means in current directory, it will create one more DRC directory. There it will create the same cell name, and here it will run the DRCs. So and
No need
okay.
to copy. No need to copy them, right? We can create our own.
Yeah, you can create your own.
So automatically when I type that name or path, even if it's not present, it will create and then run.
Yeah, even if this directory is not present, it will create on you automatically.
Okay.
Yeah, now see, if I press here, it is not asking anything whether I need to overwrite or something, because I have given different path here. Yeah, now DRC is completed. Yes. Yeah, this is DRC report. Hello.
Yes, you're audible.
Yes.
Yeah. So this is how we need to run DRCs. So you are seeing all these errors, right? This is the error report.
Okay.
So, just a second. Yeah. So let's say if I click this one. Yeah, see, it is showing here, right? Some color is highlighting here.
Yes, sir.
You understood? Sky blue color is highlighting, right?
Yeah.
Based on these, based on this report, you have to understood the error. See here it is giving error description in top. Correct, right?
Polyvinyl.
Yeah, actually, this is running with 90 nanometer rules. That is why here it is asking gate length should be greater than 1. Understood?
Yes, sir.
Okay.
How is it running for 90
9.
nanometers?
Yeah, I'll show you. Here earlier also I tried this. Here if you see, by default it is coming with 19 GPDK 90. Okay, guys, this I'll check in next class. Where is the? We need to get 45 nanometer DRC rule file.
I think if we go track by same path, I think just we have to replace that GPTK 090 to 45, right? Just let me check. Yeah,
No, is it working for you?
at least I'm able to go to that path, that Asura dot whatever that file is dot rule, right? Asura and then
Just a
DRC dot
second.
rule. DRC dot rule.
Wait.
If you take a look at that 90 nanometer path, same path. Instead, we will just have to replace that 090 to 045. I think that file, the name is different. It's drc.rule here, right? If you no, yeah. Can you just go to the extreme right cursor? Yeah. Then Asura, in that we have drc.rule, right? What I am seeing is Asura drc.rule for this 45 nanometer.
Okay, 1 second.
Yeah, Asura, then capital DRC.
Capital A.
Yeah, capital DRC. No, A is small. DRC is capital.
Ashura dot.
Asura DRC dot rule. No, nothing between Asura and DRC. Yeah. You can browse it also. Maybe if you like, we'll have to like just track that path. Can you just yeah, that's. Can you press on that double dot on second line in that directory line? Yeah, that will go take us back. No,
Okay.
Keep on pressing so that it's like cd dot dot. Yeah. Okay. We have to go back again. We have to go to slash project slash cadence we have. Yeah. Go back. Yeah. Go back again. Can you go to project now? Yeah, here it is. Scroll down. No. Yeah, inside project we have cadence, right? Okay. Yeah.
Cadence.
Yeah. Backup. Yeah. If you search for that data, cursor. Yeah. Cadence. You come down.
But see.
Same
Wait.
path I'm tracking.
Okay, just a second. Let me go inside of this.
I suggest you to take a look at current path so that you'll get quite idea what I'm trying to say. 90 nanometer path, if you just take a look at it. Yeah. Inside cadence we have libraries. Go to libraries. Yeah, there itself. Yeah. Double click this.
It is taking too much time, man, to go inside of one directory also.
Yeah. GPTK 45. We have Asura. Then we have to go to Asura. Left side. Yeah, you can see that there. Asura DRC dot rule. At the middle, around middle.
Yeah. Okay.
Same track, that RSF file. Maybe you can track. If you take a look at it, RSF include, you will see that project cadence library right at the bottom side. Same.
Yeah, I think this is the rule file for 45.
RSF also will have to do the same.
What RSF?
The bottom file we have, right? That RSF includes same will have.
Okay. 1 second. Same path.
No, maybe we'll have to like trace it back like that only. Project cadence
Okay.
library.
Then I'll do one thing. Wait. Here we don't have RSF file, right?
Yeah, drc.rsf we don't have, like two RSF file we have, but not like drc.rsf. Only we have lvs include.rsf and fill.rsf. If you see.
Yeah, fill related is that is different. Yeah, I think it's not required for DRCs.
Okay, okay.
Yeah, this is the error report file. So this stamp error means it is asking piece of an annual guard ring, one substrate guard ring. This is also same thing. This is for annual guard ring. This is for piece of guard ring. Here, these are the main errors. The maximum and minimum contact width WL should be 0.06. You understood the error, right? Hello?
Mm.
You understood or
Dim
not?
No, no. W should.
That means the contact here we have drawn contact, right? Let me highlight this. Here you can see, right, some color layer.
We have to dimming the screen. I think that is, yeah. Okay, fine.
No, not dimming. Wait just a second.
Light blue color.
It is showing some color right here.
Yeah.
Here
Yes,
and
sir.
here, all the contacts.
All contacts.
Yeah, yeah,
That,
yeah.
that means the error is related to those. So by seeing all these errors, you have to understood and you have to clean in the layout. Okay.
Got it.
Okay, sir.
Understood, right? How to run DRCs.
Got it. Got it.
Yes.
Yeah. So now I covered how to run DRC also. That's why I'm expecting by tomorrow you have to draw complete layout. Okay.
Yes, sir.
Okay, sir.
Yeah.
I will
Okay.
try.
If you don't have any question, yeah. If you don't have any question, then I'll wind up with the class. Okay.
Okay, sir.
Okay, sir.
Okay
Thank you.
then. Bye.
Bye. Tomorrow also same time, right?
Yeah. 11 to 1.
Okay, sir. Bye, sir.
Yeah. Bye.
Hello, sir. Hello. Hello,
Yeah.
sir.
Yes. Tell me.
Sir, the measurement we take randomly, sir, or like what, sir?
What measurement?
సార్ అంటే అదే సార్ ఓడి తర్వాత పాలి అవన్నీ నార్మల్ గా తీసుకోవచ్చా లేకపోతే ఎలా అని?
లేదు నార్మల్ కాదు. యూ హ్యావ్ టు ఫాలో యువర్ ఫస్ట్ నువ్వైతే డ్రా చేసి కాంటాక్ట్స్ అన్ని ప్లేస్ ట్రాన్సిస్టర్స్ ని ఫామ్ చేయి, కనెక్షన్స్ అన్ని కంప్లీట్ చేయి. తర్వాత నువ్వు ఒకసారి డిఆర్సి రన్ చేస్తే నీకు తెలిసిపోయింది ఏది ఎట్లా పెట్టాలి అని.
సరే సార్. ఓకే సార్. ఓకే సార్.
ఓకే.
థ్యాంక్ యూ సార్.
ఓకే దెన్ బాయ్.
బాయ్.